Parallel circuits, calculating current, voltage, and resistance. In a parallel circuit, the total current of the circuit is additive. It is found by adding the current across each resistor. The resistance of the circuit is found by adding the inverse of each resistor and then taking the inverse of your answer. The voltage across each resistor is equal, as is the total voltage. In the parallel circuit above, the total voltage across the system is 9 volts. The resistance across resistor 1 is 10, resistor 2 is 2, and resistor 3 is 1. Use the information to find the voltage, resistance, and current across each resistor. Always begin with what you know. We know that in a parallel circuit, the total voltage and the voltage across each resistor is equivalent. So if the total circuit voltage is 9 volts, the total voltage at each resistor is also 9. Next, we put the given resistance for each resistor into the chart. Now we apply Ohm's law and find the current across each resistor. Current is equal to voltage divided by resistance. Plugging in the values for resistor 1, the current equals 9 volts divided by a resistance of 10 ohms, giving us a current of 0.9 amps. Following the same process, we get 4.5 amps for resistor 2 and 9 amps for resistor 3. The total current across the parallel circuit is the sum of the currents across each resistor. 0.9 amps plus 4.5 amps plus 9 amps gives a total current of 14.4 amps. We still have not determined the total resistance for the circuit. Because we know the total voltage and the total current for the circuit, we can apply Ohm's law to find the total resistance. Dividing the voltage by the current gives us a resistance of 0.625 ohms. Remember that the total resistance for a parallel circuit is calculated by taking the inverse of each individual resistance, adding them together, and taking the inverse of the sum. Total resistance will therefore be smaller than the individual resistance of any one resistor.